Okay, I think we're live. Hello, hello. I mean, not live, I'm recording. Was configuring some stuff. Let me open the browser again. And here on the search menu, the search page. And welcome to another session. Today, I want to make a offline session because my internet's kind of unstable, so I think this will be better. So today I want to go back to the graphics library I'm doing right now. And so we are going to recap the unpublished session because I tried to record, but uh, there was a lot of issues on the way. So I just scrapped apart the idea, and now I'm trying to I'm gonna try to explain what I did, which was quite some time ago, so I don't know if I can remember. So let's start with that. So if we go to, I think it's option GL, and yeah, there is this. At the moment, the library is just a main.c file, and I think that's enough for what we are trying to do. But at at some point, we are going to refactor this into a library, a proper library. It's because right now it's very simple what we are doing. We don't actually need. We are only using the standard lib for C. So yeah, it is super simple what we are doing. So what I try to do, uh, I try to implement fixed point arithmetic for the library. So we don't want to use floats. We want to use fixed points for fractional types because of precision, speed, and all sort of stuff, which is very nice. And it would allow us to also use this library to make to draw on embedded systems. So because a lot of embedded systems, like the low power ones, don't have floating point capabilities. So yeah, there's that. So we are going to do the we are going to analyze the rest. Uh, so I implemented the path drawing. So the path drawing it is a structure of arrays which has the size, the capacity, and then the the path, which what is going to do, if it's going to do pathline or path fill. Pathline is already implemented, so there's that. And the different commands, at the moment we can draw rectangles and we can draw arbitrary paths, arbitrary shapes with line path, so we can draw lines. And then there is command type, color, and a union of the different commands we can have. So it's basically tagged union in that sense. We have the queue for the command queue. We have we have the context, which will at the moment stores the current color, the current buffer, the queue, and the current command, which is avoid star. I think it is. Let me use. Yeah, it is the current thing. Yeah. Maybe we don't need to do that. Maybe we can just do the to RGL command. Maybe. Oh yeah. Let me go and to make this use RGL command in the future. So yeah. Uh, Also there is some fix me, We have some to do like implement arena location, arena memory arenas for the buffer. I mean the command queue and the path list itself. So there's that. We have And then we have the command, so we can begin a path, we can move a path, and then we can end the path. So ending the path will add it to the command queue, the queue command, which just isn't a proper queue at the moment. And then we allocate the buffer, we allocate an ARGB buffer at the moment. And we are using malloc, although I think I'm going to, instead of the library, I want to make the library not allocate anything, if possible, for the buffer at least. And basically the user needs to specify the memory it's going to be used as the buffer. So, but at the moment we just allocate the buffer on the library, and we are implementing the drawing mechanism, and we have some odd, I mean kind of odd. Instead of being a return, I actually wanted to fail. So maybe to fail the program, we can force it to dereference a null pointer. We can cast this into a integer type, a int pointer, and then we can try to dereference this. Yeah. Yeah, we can, and then we can specify a macro. So crash text. And then we do also we need to do this stuff with multiple lines, which is annoying as hell. So we are going to printf the text, and then we are going to make this tactic to basically crash the program. Because I think the referencing null pointer is not valid C anyway, so and then wrap this on a do while. So there's that. Okay, so we're printing the text and then while 0, and I think actually just going to do this, and then we can just command type is not expected rectangle type, and there's a warning which isn't an error, so there's that. Maybe the warning because we are trying to do this, and yeah, it's going to complain about it. So maybe we're not doing that. No, we need to do that because I want it to crash. Because if you're going to use like GDB to debug on the future, it's going to be more helpful if we crash so we can get stack trace and stuff. So yeah, now it's a proper crash. And I think it's better for debugging purposes. So yeah, there's that. Okay, so uh, going back to the recap, we implemented on a session to draw rectangle, which we did on stream. And the other session I've implemented path drawing, which is at the moment it's only drawing the a line. And this is the algorithm. So it converts the fixed point to integer because the algorithm we are using works on integer types. And this is basically the Bressingham line algorithm. So we can draw arbitrary line segments, and it is pretty cool because it's also kind of efficient. We can set the color. We have the draw, which will iterate on the queue, and then the queue has a CMD, and then it will switch to the command type and call the write function for it. And then we also have the write ppm file, so we can see the output. We have the main, which we are using to test the library's ability. So we create the buffer, we create the context, we set the width and height, we allocate the buffer, we then create the rectangle, although we are not using the rectangle at the moment, so we can remove this. We set the color, so we can set the ARGB value separately. We have the begin path. We have a path move to move. We are creating 3 points. So there's the start, and this is the end. And when we are ending, when we are drawing the paths, we are just we are getting when we are drawing the last one, we are getting the first one again to connect with another line. So it is a proper closed shape. And then we write the output, and then we exit the program. So the program at the moment looks like this. Let me remove the what is this? Oh wait, I know why. It's because there's another, it's my other, I think it's because it's another user. Yeah. Okay, so we're going to compile. So RGL like this, I mean like this. And then we are specifying this, and then we can run and then visualize this here, and there's a triangle. It is a triangle, a upside down triangle, but it is a triangle. So we can draw basically any shape. So let me try to draw, and I misconfigured this. Empty also gel. So let me try to draw and square. So a square is like this, and then we put this 600, and then 600 to 0. They should give a square. Oh no, I haven't. Yeah, this gives a square, although it's clipping. Although it's clipping, so that's an issue. So we need to fix this later. So 799, 799, 599, 5, 599, and it's still clipping. Of course I haven't ran the thing. I mean, wait, no, I haven't compiled. Actually, let me. And now it's correct. Yeah, it was off by one, and now it feels like it's correct now. So yeah, there's that. Okay, we can draw. So basically, we can draw arbitrary shapes at the moment, and also we can. And by arbitrary, I think it's really arbitrary because I think we can do this this type of stuff. So if I reorder to do this, it should generate this kind of shape. Yeah, this funny shape here. So yeah, it is pretty cool. So this was the recap. Now I want to implement fill and stroke for path drawing. So the stroke, it's kind of done. Maybe we want to have some custom code for that, like setting the stroke size. But let's actually implement the path filling. So for filling the path, we need to So we have some ideas, and I'm going to GIMP to show the idea that I have for implementing it. So we are going to draw like that, and I want the bucket. I want to do a black screen. Okay, so let us suppose we have the same shape that I showed later, like this. So what we need to do to fill this path. So let's iterate row by row. We can make uh we can cast a point. Let me change the color to something like red. We can cast a pointer and detect if that hits. If that hits, we mark the next regions as inside, and if it hits another point, it marks this region as outside. And then we can, so basically we need a structure to store the edges. I mean, this won't work for shapes that have these kind of intersections because, yeah, it is going to be messy if if we do this on a pixel level. If we do this on like this intersection, which is only one pixel, it will detect the rest of the pixels as it needs filling, which is incorrect and will cause problems. So we need a way to detect the edges of the shape we are trying to fill in. And one way to do this is by an edge table. So, which is not a literal table. So let us read the AI summary. The process of rasterizing a path using an edge table involves organizing polygon edges for efficient scanline-based rendering. The algorithm begins by creating an edge table that stores edges of the polygon, sorted by their sorry, sorted by their minimum y coordinate. Horizontal edges are typically excluded from the ET as they are handled by the edges they connect to. For each scanline, the algorithm processes the edge table by transferring relevant edges into an active edge table, which maintains edges intersecting the current scanline. The AAT is sorted by X coordinate to determine the order of pixel rendering. As the scanline advances, the X coordinates of active edges are updated based on their slope, and edges that no longer intersect the scanline, those with Ymax equal to the current Y, are removed from the AAT. The rasterization proceeds by drawing pixels between pairs of X coordinates from the AAT using even-odd rule or similar method to determine which pixels lie within the path. This approach is work efficient and cache friendly as it avoids processing pixels outside the path and only considers active edges per scan line. The use of an active edge table significantly optimizes performance by leveraging the fact that edges intersecting one scanline are likely to intersect the next. In modern implementation, so okay, it's okay, so we have and we need to have an edge table. So we need to organize the polygon edges. So And these edges need to be sorted by the minimum y coordinate. Mm-hmm. So we have this font here, which is an assignment help for the for Stanford. If it's going to load, we also have some stuff that unblocked at the moment, I guess, or it's not available. Maybe this will have, okay, we have. Okay, we have. So we have the interface. Okay, this is a program that we can edit we can add points dynamically and make polygons, which is very cool. It's very cool. And we have is this loaded correctly? Okay, it is. Although the images don't seem to be loaded. Okay, and this doesn't have, this has nothing on it. Okay, so it seems that we have the algorithm. We need to create the edge table. Mm-hmm. Then, yeah. And then we have a bucket sorted edge table for polygon. So it is an array. I think an array of pointers. And with that, we have the edge function EF. No, EF, it is the, okay. Okay, I see. EF, it's this, basically. So we have a point to F, E, D, C, B, A. So and F. So it's storing the stuff, some stuff, and then if we see, so, and it's sorted by the Y coordinate. So 1, it's because the B is on position 1. So it gets this vertex and then AB and BC. Uh-huh. And then there is the 3 because A is on 3, so and it's because it's on and it's connected by F, so it's FA. Mm-hmm. And also AB, but there is BC. Maybe the order of the points doesn't matter, so yeah. And then the first position that we start is the maximum Y. Oh, I see. So this is the minimum Y. And then we start the maximum Y on the AB line. and we see it seems to be sorted by the minimum of Ymax, by the ascending order of Ymax. So 3, because A is lower than C, it's being first. So yeah, I get it. So we have, so we get to A because A is on 3. And also we get the invert, the, I guess this is the slope. And lambda is null from what I see. Okay. 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 So I see. I see. So we get 3, 9, 11 because D is on 11. No. We get 5 because C is on 5. And then we get E because E is lower than F and D. I see. Yeah. So with this, so we need to have a collection of points. And because at the program we are doing, the points are sorted by the order of what it's drawing. So point A, then point B, so it infers that A goes to B. Something like this. We don't have like some other system. We don't have a vert index buffer for referencing. So we don't have a system for like referencing the same point multiple times, because I want to make a simple system for UI, not actual graphics rendering. Although I can consider this on the future. So there might be some possibility. So okay. So we need to construct the edge table, which is basically this. So it's not that hard actually. Okay, so to implement so for drawing the path, uh, maybe I want to make another function, and then there we are going to switch the SMD type, and if it's path, it's going to use RGL draw path. I mean draw stroke. Maybe I want to rename it like this. And we are going to pass buff and SMD. Also doing like this. Oh yeah, and then because we are doing C and C is stupid, we need to declare it on the other way around. Then we make a case for case fill. It is. math line path fill. So yeah, like this. Okay, and then we are going to, I mean, so RGL, draw, fill, buff, and then SIMD. And then we can substitute this. Oh yeah, we need the color. Path, color, call, path, call. Then we are going to have path and call. And then path, word, like this. Yeah, seems right. So we can, and also it's RGL. So we can implement the draw fill function. So okay, so basically we can have so we are going to have an edge table. I don't want it to make for every y coordinate because it's going to allocate a very high uh, it's going to allocate a lot of indexes which we are going to need it. So because I think we are going to iterate on a few points, uh, having an edge, ta edge table with every y coordinate. So for example, on this screen, which is uh, it is 1800 pixels of height, it's going to waste a lot of memory. So I don't think it's smart to do that, but instead making a list and ordering. So basically the list would iterate the y coordinate instead of accessing the element directly, which is kinda slow, although it's not really because since it's going to be smaller, I think it's going to fit on a cache line anyway. So yeah, there's that. So okay, so we are going to declare and maybe a type. I don't. Uh, can I declare types here? I can. I can. So Ymax, it's going to be uh, RGL fixed, the Y mass, and then X, and I'll point to the next node. So it's going to be like this. So yeah. Maybe we can construct this on another part of the library, but at the moment I'm going to do it like here. So because it is an useful is it, I think we're trying to do a lot of things that aren't really necessary, and I think the edge table it's very useful for testing some other stuff like damaged areas and something like this. So yeah, we're gonna have a table and we are going to maybe like this, and I is less than path list size plus I, and we want to sort the elements. So we are going to start the wyming, and wyming is going to be int in 32 max, because why? But I think RGL fix instant int 32, yeah. So wyming, if so we're going to check if path y list of I is less than ymin. We are going to set ymin equals to path, ymin I, ymin I dx. So we are going to do two things. So we are going to do ymin equals to path y list of I, and we are going to set the y in idx to I. Or we can just track the index. Like this. Yeah, I think it's smarter. I think it's smarter. And because we are not storing the ymin, I think we are going to have to duplicate the ymin. Although we can also do something like this. And yeah, so we start the head. And I'm going to use unsigned because we are going to do subtraction. So yeah, and we can do a little trick. So we sorted this. Uh, we are sorting this list. We can mm, tough. It's tough because I want to make the sorting also efficient, but I don't want to think a lot about it. So I think I'm just going to uh, implement a simple sorting algorithm like bubble sort. Maybe starting with I. So I'm going to uh, this allocates by, I mean, it's kind of funny. It is kind of funny, actually. So yeah, it is kind of funny because we also need to calculate the slope. Actually, we can do this. So, okay. So y my mean idx. So we got the minimum. We can insert it on. So let's do a naive uh, implementation. Uh, just store the amount of edge head, but it's not. But to be quicker on this session, I'm going to make this change. So yeah. So we can think about, so when we have this, so we can do table I equals to how we can have an so we have an edge head. Oh yeah, we access it like this. So we set the winding to a path, y list, y min idx. What if there's a more points on the same line? Do we need to? Oh, I think we need to start that. Because what about polygons that edges that cross and and yeah, self-intersecting polygons like this? What would happen on this case? Because I've on the method I'm doing it overwrites. I think. Does it? I mean, we're not doing a table, so maybe not. Maybe not. Or maybe on this example that it shows, we just append another stuff. And also we start the x main. Oh, so it's not x, it's x main. Hmm. This is strange. I'm going to, I'm going to implement this, but I am very skeptical about it. Okay, so this polygon, we are getting the lower one, so this polygon stars the edge for so this polygon stars this, and then so it needs the x mean, which is I mean it's not correct in any way. It is no. It because does it really matter? Because we're getting the by the we also need to compare. Also, I spotted a bug. So we also need to order the so we also need to get the x mean, and then there's x mean. So it's going to be uh actually it's going to actually j it's going to be a normal integer. Actually no, we can do something fancier. So we can do I plus j minus 1. So we get this, and then we can do modulo of path list size, and maybe putting this on a separate variable, so something like so we're going to get the previous times minus 1. No, actually, how? Never mind. Let's do -1, 0, 1. So this is going to j times 1 -1 times 1 will be 1, 0 times 1 will be 0, and 1 times 1 will be 1. Yeah, fancy math. Very fancy math. Also to be consistent. We are getting the x-mean. So we are ordering. We are trying to get the minimum x of these points. And also we are calculating the slope. Mm, I don't quite understand this. If there is like overlapping x coordinate lines, x coordinate points. Oh, x means the x at minimum, y for the edge. For x means the x at the minimum, y for the edge, not necessarily the minimum x of the edge. So because AB x at the minimum y. Oh, I see. So we don't need to sort it. So it's so table. So we get node uh x mean will be the will be path x list of y in idx. This. So I guess we can just rename to x. What? Okay. And then node. Uh, and we also need to make the same trick. So -1, j less than j less than 1 plus j, and then uh, x equals to path, I mean y is actual y list of I mean we could only do that from the start. So we can do I times j, I plus j times -1 times 1 modulo modulo of path list size. And if y is equal to is max y max idx. And if it's not the y max, and if it's not, we are just going to set it to I initially, I think. No, the y max. We are going to don't include horizontal edges. Hmm. This is way harder than I imagined. I wonder why. I feel like most of this material is gate kept, but I might be wrong and I might be dumb. So take this with a grain of salt, but I have quite a difficult time trying to find good material for for this stuff. Maybe because it's not the kind of math you study at school, you study more on university. And because I'm not at university at the moment, that's why it's confusing. No, but this is wrong. Okay, and don't include horizontal edges. So these edges, I don't get it by horizontal edges because in this example it doesn't have an horizontal edge. Mm, I mean, this is very difficult. Maybe I want to find more material about it. So, Polygon filling. Scanline by scanline. Maybe this link. Let me see. Filling a polygon. Okay, let's just create a table. Let's just create a table. So uh, let's do a table. Let me do this. Right. Um, Why is this incompatible? Why is this a problem? Oh, it wants... Am I tripping? Am I tripping? Oh, we don't need to allocate. Oh, yeah. Mm-hmm. And then we can... I mean, it's still confusing. Okay. Mm. So we need to start the edges. It's not sorting what we are doing. Hmm. Hmm. So we need to get the global edge table. All edges sorted by Wyoming. Ignore. Okay, so we can just ignore this edge. What if more than one vertex shares the same location? And also these doesn't cover polygons that are defined by curves. Yeah, because we're just drawing we just have the slope and the slope. And in this case, don't, we need more than the slope. We need the control points, the spline or splines. Yeah. So get the y. This is the y mean. I mean, just y. Get the y max. Mhm. And we calculate the slope, which is uh, so we need to get the slope. We have the so we have the x, we have y max. Hmm. I'm getting so confused. Line slope formula. I kind of forgot. I mean, there are a bunch. Maybe Khan Academy can help. Changing X and changing Y. Yeah, that's what I was thinking about. So we need to actually have Let's do it like this. And we are calculating the change of x divided by change of y. Guess just do a float. Yeah. Okay. Oh yeah, we don't need casting. Mm-hmm. Hmm. Okay, we constructed the edge table. Now there is a structure called the... No, there is just the edge table. So how does this... So now we need to calculate the distance of a point between a line. Because now we have the table. But I mean, I don't understand a thing about this code. Maybe because I don't exactly understand the fundamentals, but yeah. Hmm. Okay, I have the table. I have now the table. What should I do with the table? So we iterate by we iterate the coordinates. So mm, so Hmm. So we can start by Mhm. Table in active. Mm-hmm. Mm, so you get the rhyming. So we need to take care of So what do I need to do? Now this. It's been 2 hours of recording. So what? So we have x min, the minimum x of the edge. Now we need to test if the what side the point it is on the line. This, this is very hard. Mhm. Mm, So we can plug and we can plug the points and see if it's a positive value, I think. So we put x. No, but I don't have the line. This is so confusing. Because how can I know? Because I only have the y, the x, and the slope. I don't have the offset. So how do I even? I mean, I need an active edge table. We don't have the max X. So this is not a point exactly. It's a vector. This is mind wrapping. Let me get this. This is how. How much time? 2 hours on this. How? Yeah, maybe I should link this stuff. Link this and the assignment. This resource isn't that helpful. Only the help is more helpful. Yeah, maybe I should start studying computer graphics. Yeah. It's getting complicated. So yeah, I'm gonna stop it here. Gonna uh, save the file in the description. Yeah, that's correct. So yeah, I'm gonna stop it right there. Thank you everyone for watching the video, and hope I showed how much I don't know about this stuff and how much how much I need to learn on the background. So yeah, I'm gonna do it like that, and I'll see you in the next video. Bye bye.